In this lecture, I am going to explain you how to convert a finite automata to regular expression using state equation method. So first few minutes are very important. See here. Let me define a variable a which is different from the state, okay? But I use same variables. Don't get confused. So this a represents collection of strings on which we go to final state if you start at a. Similarly, b represents set of strings on which we go to final state if I start at start state b. Now, similarly, C is nothing but collection of strings on which we can go to some final state when we start at C. Okay, that's it. For example, so when you start at A, for what strings you go to final state? One is 0, right? Second one, anything else? You take 0, maybe 0, 0. There are so many things. 0, 0, 0. Otherwise, take 0, 1, 0, 0. I'm just giving an example, okay, don't worry. So we are not listing out all possible strings, but we are describing, so the collection is A. Similarly, B, if you tell me one example string which eventually lead us to final state when we started B, that is compulsory. When you started B, so then maybe epsilon, right? You don't take any input, then we will be at final because since B is a final. Similarly, 0, right? 0, 0, so on. Now let's talk about C. Since C is a final state, on epsilon we will go to final when you started here, and anything else, yeah, take 0, 0, 1 or 0, 0, 0, 0, 1, so many, but I'm just giving few examples. Now what are we going to do is we are writing state equations for A, B, C, where same thing. What is A? A is nothing but collection of strings which eventually lead us to go to final state when we start at A. That's it. Same way B, C. Now let me write a state equation for A. So state equation for A is nothing but, so how to go to what strings eventually lead us to go to final state? Maybe if I take 0 first, okay, if I take 0, I will go to what? B, right? So that's why then once you go to B, then ask B, my dear B, because of 0 I came to you. Now actually I want to go to, I started at A, I want to go to final state. So do you have any strings? Tell me the strings on which I will go to final state. Then according to the definition, when you start at B, because you are starting at B after taking 0, then this class, this B represents collection of such strings which eventually lead us to go to final state. Because of that, I concatenate 0 with all such strings, then definitely I will go to final. For example, tell me one example string which is in B. See, 1, 0, 0. On 1, 0, 0, you are going to final or not? Yes, when you started B. Now, if you concatenate 0 and 1, 0, 0, what is going to happen? You see, for 0 we will come here, then 100's definition you know, because of 100 we will go to some final state. That's why definitely on 0100 will go to final. So that's why all 0 B represents collection of strings on which we will go to final state. Same way, anything is there any other edge? No, right? Just stop it. A equal to 0 B. Now let me write for B. When you are at B, that's the question. So what is the description of B? When you are at B, what collection of strings will eventually lead you to final state? Ask yourself. Then answer will be, when you are at B, I take let's say 0. Then again I will come back to B. Then now the question is again reduced to, what collection of strings will eventually lead me to go to final when I am at B? B. That's why 0B. Correct? So that's why take 0 and take any string of B. Definitely you will go to final. That's the definition of B. Now, anything else? If you take 1, then this time you will come here, then take one of the string in C, because the definition of C is nothing but collection of strings which eventually lead you to final when you start at C. That's why 1C. So 0B plus 1C is the answer. Plus there is one more thing we have forgotten. That is, when you are at B, already you are at final. Then by taking nothing or epsilon string also you will go to final, right? That's why we have to add this. Now similarly let me write for C. You are here, then 1 is epsilon, because on epsilon you will be in final, or you take 0, because of that you will go to A. Then now take one of the string in A which will definitely eventually lead you to final, or anything else. That's it. So 0A plus epsilon, let me write it. So after writing the state equations, we have to simplify it. We have to solve them. So to solve them, we are going to use our famous, famous formula, that is Arden's lemma. You remember it, right? So Arden's lemma. Let me write the Arden's lemma. if you have any equation like x equal to rx plus s, okay, then r star s is a solution, correct? And especially when r doesn't contain epsilon, then r star s is the one and only one solution. Now we will see how it can be applicable here. So what I am going to do is, since I have three variables, let me number them like this: 1, 2, 3. This is the third number, right? First of all, I go to highest number and I will try to target this variable c. In the variable c, like in this equation, somehow I will eliminate the variable c if there is a variable c. But since in this equation you don't have variable c, that means we have eliminated already. Okay. Now, so directly I cannot apply Arden's lemma, and I don't want to apply because that is not applicable here. Now in the place of from now onwards c anywhere, I will always substitute 0a plus epsilon. Assume that let's say you have something like 1c, then what you are going to do? Okay, let me write here rather than here. I will write. Example, if we had an equation like 0a plus epsilon plus let's say 1c, what are you going to do? Simply I eliminate variable c from this equation, you see, using the Arden's lemma. That is where I use the Arden's lemma. For me, this entire thing is s, this is r, right? Rx plus s. So then the solution is r star s. See here, r doesn't contain epsilon, that's why this is one and only one solution, that is r star 1 star dot s 0a plus epsilon, right? Now can I say that in my RHS there is no variable c, that means we have eliminated variable c. In that way successfully we have to eliminate all the variables, then you will end up with expressions, regular expressions. Now here you don't need to do anything. Now let's go to B. Now here I will show you how to eliminate variable b. Let me take this. In the place of c, now happily you write 0a plus epsilon. Okay. Now I am writing here 1c is nothing but 0a plus epsilon. Let me rewrite here. So b equal to 0b plus 1 dot c. c is nothing but 0a plus epsilon plus epsilon. Now can I say that this is b equal to 0b plus something. Again r x plus s, right? So x equal to rx plus s. Then solution is r star s. So what is r star s here? R is 0, 0 star s. S is nothing but this entire thing, 1, 0a. So let me directly write 1, 0a plus epsilon. Okay. Now be careful. It is 0 star dot, this entire thing is 1 unit, correct? Yeah. Now let's go to a. In the place of b, we write this entire thing, so that I can eliminate variable b here. Then what I get? I get a equal to 0. What is b? 0 star and 1, 0a plus epsilon, right? Okay. Let me simplify it. A equal to 0, 0 star 1, 0a, correct? Let me do this part first. 1, 0a plus 1 epsilon 1, right? Plus epsilon. Now 0, 0 star 1, 0a plus 0, 0 star dot 1 plus epsilon. Okay. Now you see a equal to 0, 0 star something dot a plus this one. Again Arden's lemma. This is r, this is s, r star s. So 0, 0 star 1, 0 whole star dot s, 0, 0 star dot 1 plus epsilon. Of course you can further simplify it if you want, but that is not our ultimate goal. I wanted to write expressions or regular expressions for variables a, b, c. Among them, what is the regular expression for our finite automata? See, just focus on the start state's regular expression, description. What is it? So start state's description is collection of strings which eventually lead us to some final state when we start at a. See, that is what that is what represented by this finite automata, right? You just forget about this one. You tell me what are the strings accepted by this machine. For that you have to start at a and you have to go to some final state on some string, right? Now a also describing the same thing, that's why. So the regular expression for this one is nothing but the regular expression is nothing but the regular expression which represents the language of this machine. That's it. So finally, so we got the regular expression for finite automata. Remember one thing, simply the equation for the start state is the answer. Now We will see one more example to get the more clarity.